Okay, now let's talk about the concept of overflowing. Here I've declared a variable of type byte, call it number, and assign it to 255. As I told you earlier in the slides, 255 is the largest value you can store in a byte. Now in the next line, I'm increasing the value of number by 1 and trying to store 256 in the number. But if you compile the application and display number on the console, you will see 0. And this is what we call overflowing. So we have exceeded the boundary of the byte data type. In C#, by default, we don't have overflow checking, which means we can modify the value of a variable at runtime, and if we go beyond the boundary of its underlying data type, we'll get overflow. Now, sometimes this is not desirable in your application. You want to stop overflowing. If that's the case, you need to use the checked keyword. So here is how it works. We have the checked keyword, followed by curly braces, which indicate a code block. And inside that block, we have the variable declaration and any kind of arithmetic operations. With this code, overflow will not happen at runtime. Instead, an exception will be thrown, and the program will crash unless you handle the exception. The topic of exceptions is an advanced topic, and I have covered it in my C# Advanced course. For now, all I want you to know is that if you use the checked keyword, overflow will not happen, and instead, the program will throw an exception. Now, do we really need that in reality? Honestly, I have never ever came across this situation. Because if I was concerned that in this case my number variable would overflow, I would just simply use the short data type instead of byte. But I decided to include the concept of overflowing because I wanted my C# course to be comprehensive. So just be aware of that in case you hear about overflowing somewhere, but you're probably not going to use that in the real world. In the next lecture, we're going to talk about the concept of scope.